So welcome to this DCG video on 2013 DB mock exam. So we've got a miner in a borehole with the position of two boreholes are represented by the projection of the two skewed lines A, B and C, D. To facilitate access between the boreholes, a horizontal borehole is required. So going horizontally between the two boreholes. And we will have to determine the projections of the shortest horizontal line between them, so the shortest possible horizontal line between them, and the reason for that is the cheapest way to join them. Determine and indicate the length of the shortest distance. So I'm going to draw a horizontal line from D. Now this can be, you can draw your horizontal line from any point. The key is, if you pick a point and draw horizontally from it, you need to remember that from the opposite end of that line you have to go parallel to the other skewed line. So I'm going to go parallel to line AB here from point C. So this is parallel to line AB. I'm going to label that point P. Now P to D is going to be called a strike line because it is parallel to the XY line elevation. So it will be a true length in plan because the strike is parallel to the HP. So I'm going to drop point P down to plan, and if I went parallel to line A to B from point C in elevation, I go parallel to line A to B in plan from point C, because parallel lines are parallel in every orthographic view. So this is point P. I'm going to join that to point D. So I'm going to join that to point D. Now, this is our strike line, and it's a true length. And we're going to look along this true length line because if you look along the true length of a line, it projects as a point. And when that line, true length line projects as a point, okay, the surface PCB, the lamina, is going to project as an edge view, and the two skewed lines will appear parallel because surface PCD projects as an edge and line AB is parallel to line PC. Okay, or I should say, yeah, no, that's right, AB is parallel to PC, so the two skewed lines will project as parallel because line AB is parallel to surface PCD. So I projected along line PD, the strike line, and I'm taking an auxiliary elevation, okay, here. So I'm going to draw in my X1, Y1 line. Oh, sorry, let's have to set them up again. So I'm drawing in my X1, Y1 line. I'm going to get my heights from elevation. So I'll be taking the heights of these from elevation. Now B is on our XY line in elevation, so B1 is on our X1, Y1 line. Now compass set to the height of A. Find A in plan, follow it along. There's point A. For now we're going to do C and D and point P. Okay, so C and then D. So compass on the XY line up to point D, taking the height of D. Follow D along, mark it in here. Now, moment of truth. These two skewed lines have to appear parallel in our auxiliary elevation. So we connect them together. So this was C1, D1, okay, P1 slash D1, B1, A1. Now we're going to have to look along the X1, Y1 line to get the shortest horizontal distance, because the x1, y1 line is the horizontal plane. Okay, so it's got that's why we're looking parallel to the x1, y1 line, because the shortest horizontal distance line has to project as a point. So projected parallel to the x1, y1 line. I'm just going to draw in a datum line closer to my plan view, parallel to my x1, y1 line, to take my heights from. Okay, so I'm going to get my compass, take the distance from the datum to point C. I have to draw in my x2, y2 line. So I follow my point C up here. So there's my point C2. Okay, put my compass on the datum line to point B. So there we go, follow B along here, mark it in, datum line to point A. So compass to point A, follow A along here, mark A in. I've done B, I need to do D. So compass on the datum line, join to D, follow D along here, mark it in. Now, so here's point A2, D2, and B2. So I'm going to join B2 to A2. Okay, and D2 to C2. Now, here's a point view of the shortest, okay, horizontal distance. Now I have to project this back to, okay, my auxiliary elevation and then my plan view. So I'm going to project this back down. So here's the shortest horizontal distance here. Now I need to project this to plan. So I'm going to bring this point back down to C, and this one back down to A. So I'm just going to move my visualizer for a moment, and I'm going to connect them together. Funnily enough, they happen to be, okay, parallel to the x1, y1 line. So do, funnily enough, and that's going to happen with them all because it's a true length here, and for it to be a true length here, it has to be parallel to the x1, y1 line in plan. Okay, and it's also true length here because it projects as a point up there in our second auxiliary. Now we're going to project this to elevation, and this is probably the hardest part in skewed lines, is making sure that this line is horizontal in elevation. It's very, very hard. So that's on line A to B, so it stops there, and on line C to D. Okay, mine, okay, is in fairness a tiny bit out, so I would say just draw the line horizontally there to deal with it. Okay, and the true length, it says determine and indicate this distance. So if you don't write it, okay, you're not going to get, or you're going to lose marks. So our distance there, okay, is going to be 14 millimeters. Okay, so thank you, bye bye.